So this is a continuation of our ellipse lessons. These are the formulas we learned the other day. We learned how to graph a horizontal ellipse or a vertical ellipse. And there were different formulas. And all our formulas, again, we're having the center of the ellipse be at the origin. So these formulas are specifically for when the center is at the origin. First thing we're going to learn how to do is graph this in our TI-Nspire. I'm going to show you two ways to do this. Well, one, I think we'd have to do a little bit of work beforehand. So we could solve this for y squared. So that would mean kind of moving that to the other side. We'd have y squared over 36 equals 1 minus x squared over 9. Maybe multiply both sides by 36. Multiply by 36. And that cancels. And you get y squared equals, I guess I can multiply that, 36 minus 36x squared over 9. And then you take the square root of both sides. Don't forget, plus or minus. I know that's a mess over there. Y equals plus or minus the square root of 36 minus 36 over 9. I guess 36 over 9, I mean, I could write that 4. I'm not that interested in simplifying here. You're certainly welcome to, but you don't have to. But 36 over 9 is 4, so I just simplified it. And so you're going to graph that in your TI-Nspire. So let's see how to do that. So get your TI-Nspire out, and we're going to graph, so square root of 36 minus 4x squared. You can see that's half the ellipse. To graph the other half, again, you just graph, I guess you'd say a negative square root of 36 minus 4x squared. And you can see the bottom half of the ellipse. So to graph an ellipse, it really takes two functions to make one ellipse, because ellipse is not a function. There's another way to graph an ellipse. So if you hit add a new graph page, it's kind of a cool way. If you hit the delete key, so the delete key is right here. If you have the newest operating system, you'll have something called relation. And now I can just type it in like it looks right there. I can type in x squared over 9 plus y squared over 36 equals 1. If you do that and press enter, it's not solve for x, not solve for y, it'll still graph it all at one time using the relation method of graph entry. So there's two ways to graph an ellipse in your calculator. Let's go the old-fashioned way here. So let's learn how to kind of work backwards and get the equation for an ellipse. So let me get some graph paper out here. Okay, so we're going to graph here. So focus is at 0, 3, so that looks like right there might be a focus point. 0, negative 3, that's also a focus point. It's an F right there, in case you didn't catch that. Vertex is at 0, 5, so that's a V there and a V there for vertex. Now you can probably tell, hopefully, that this is definitely a vertical ellipse, because again the focus points here and here have to be on the kind of the vertical part. That's called the major axis that goes vertically there. So the focus points are always on the major axis. So that gives us a bunch of information. We know that this is 0, c, so c is 3. We know 0, 5, so a is 5. There's a formula you learned for this, which was c squared equals a squared minus b squared. So 9 equals 25 minus b squared. So b squared equals 25 minus 9, which is 16, so b equals 4. So if I go to the right 4 and make a point, and to the left 4 units and make a point, those are my kind of endpoints of the ellipse there, so I can actually draw the ellipse. It's beautiful. Looks like a vertical ellipse to me. Those are the focus points inside of there, and I've drawn my graph. And so that's really all you have to do as far as, I guess you could label the ordered pairs. They're already labeled off here to the side though for some of those points, and you've got it. Find the equation of the ellipse. So that, again, this is, I think it helps to make a little sketch of this ellipse. Even if you don't use graph paper, like I'm okay if you just want to kind of sketch out something here. Okay, major axis is 10, it's on the x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I have, it looks like in all of our ellipses are going to have a center at 0, 0. So I'm going to assume the center is 0, 0. The focus is on the x-axis. This is the length of the major axis. So those are vertex points right there. The ellipse passes through the point square root of 5 to come at 2. So I don't know exactly where square root of 5 is. That's like 2 point something. So 2 point something comma 2. Somewhere around here is the point square root of 5 comma 2. So this graph roughly kind of looks like that. It's going to roughly look like that. I'm not sure exactly where it crosses the x-axis there. We don't know a whole lot of information. We do know some information though. If you think about the form of the equation, it's going to be x squared over, so x squared over a squared plus y squared over b squared equals 1. So if you have that equation, if you think about it, we have x, we have y. We know that this distance is a. So a is, what, 5? So I think we know everything but b. So we can plug all that stuff in. We can say x squared is square root of 5 squared over a squared, which is 5 squared, plus y squared, which is 2 squared, over b. And by the way, these are actually squared down here, so this is 5 squared, and this is b squared down there. Okay, so now equals 1. Now it's just a matter of solving this equation, so we can do that. I think it's going to take a little bit of work. But we have 5 over 25 plus 4 over b squared equals 1. Let's move that over to the other side. So we have, let's see, 4 over b squared equals 1 minus 5 over that, which is 20 over 25. 1 minus 5 over 25 is 20 over 25. I guess we could cross multiply and solve if we want to here. 100 equals 20b squared. B squared equals, what's 100 divided by 20 is what, 5? So b equals square root of 5. Once you have b, we really have our equation, because really all you need is a and b to write your equation. We know that x and y are actually just x and y there, so we'd have x squared over a squared, which is 25, plus y squared over, I think b was square root of 5, so square root of 5 squared is 5, equals 1. And so we would go up 2.5 units approximately, whatever the square root of 5 is there, to get that y value right there. To graph that point, if we need to graph it. So this distance here is actually the square root of 5 vertically. And you got the graph. And then a little tougher, I think this one, using eccentricity. So that e there is eccentricity. Eccentricity is 4 over 5. We know the formula is e equals c over a. So if that's 4 over 5, you might think that c is 4 and a is 5. But it says c is 8. Well, how is that possible? We know that the ratio of c to a should be 4 to 5. So if the ratio is 4 to 5, but C is actually 8, and we don't know what A is, we could figure out what that would be, right? Cross multiply this, you get 40 equals 4A. You might just know what the answer is. So A equals 10. So we can figure out that now C is 8, A is 10. If you know those two, we can figure out the rest. C squared equals A squared minus B squared. It's a lot of formulas for this stuff here, right? So this would be 64 equals 100 minus B squared. So B squared equals 36. B equals 6. So you found A, B, and C. Find an equation for the ellipse. We know that we're assuming for all these ellipses today that the vertex is at the origin, so we know that's kind of the form of it. Underneath, this is what kind of, now I'm really thinking about this. We really don't know which type of ellipse this is. We would need to be given one more piece of information. Let's say this was a vertical ellipse. So let's say this is a vertical ellipse. It was vertical, that means the larger number, let's see, between A is 10, so that would mean 10 squared goes underneath there, or 100. 6 squared would go here for B. And that would be the equation for the vertical ellipse. It didn't tell us enough information, so it'd have to tell us, hey, this is vertical, hey, this is horizontal, and then we'd be able to solve that. That's the end of the lesson.